Hello everyone here, this is Eason Lee from Think Academy Singapore. Today we are going to talk about angles on clocks. In NMOS Round 1, every year there is a question that asks us to calculate the angle on the clock formed by the minute hand and the hour hand. So this question looks like a geometry problem as it's calculating the angles, but in fact, the most efficient way to solve it is use some distance word problem. Yeah, it's treated like a word problem. So let's find out the basic argument we need to know and see the question. First of all, a normal clock here, right? It's a circle, and there are 12 numbers on it. So just write a few of them. So the angle between each junction numbers is 30 degrees, so that we should know. Then, when we find the minute hand and hour hand, let's calculate its speed in degree. So the minute hand, it travels totally around in an hour, which is 16 minutes. So its speed is, one circle, which is 330 degrees, divided by 60, which is 6 degrees per minute. The hour hand, on the other hand, it travels only 30 degrees, 1 to 2 or 2 to 3, right? Only 30 degrees in an hour. So its speed is 0.5 degrees per minute. This is 60 here. So this is the speed that the minute hand and hour hand traveled for each minute. And we all know that both the minute hand and the hour hand travel clockwise. So, in this word problem, we call it a catching up problem. It's chasing, right? The minute hand is keep chasing the hour hand. So about the chasing, we should know the difference of speed, which is much more important. So we should remember this number. The difference on speed would be 5.5 degrees per minute. So every minute, the minute hand travels 5.5 degrees more than the hour hand. And in fact, the angles formed by the minute hand and hour hand just is the difference on distance. So if we know this, the questions can easily be solved mostly in a same way. So first, let's look at a very typical question come from the 2021. It's a 2-point question, but maybe this difficulty can be a 1-point question. I think they share the same difficulty. So the clock here, we know the time is 3:34, and we want to calculate the angle here. This question is we know the time and want to calculate the angle. There are many ways to do it, but now I want to introduce you maybe not the most simple way, but the most common way that you can use this method to solve nearly all the problems. That is, if we want to calculate the angle, we start from a 3 o'clock. That is, we calculate from integral time, which is 3 o'clock, 4 o'clock, or like that. So, the time is 3:34. Let's trace back to the 3 o'clock. On 3 o'clock, we can easily find the angles formed by minute hand and hour hand, right? So it's a 90 degree. But just do not write 90 down here, as on a clock, angle has its directions, which is clockwise. So when we write the angles, if the minute hand is in front of the hour hand clockwise, we name the angle a plus angle. But if the minute hand is at the back of the hour hand, like this case, we call it a minus angle. So this time we write it as a minus 90 degrees. Then, let's look out. The time travels in 34 minutes, right? So 34 minutes later, the minute hand travels, the hour hand travels. We all know that it's traveling in the same direction, so we can find the difference of their speed and the difference of their distance. So, as we all know, the difference on speed is 5.5 degrees per minute. So then, the difference on distance or on degree should be 5.5 times 34 minutes, which is 187 degrees. So in this time, the minute hand travels 187 degrees more than the hour hand. So what is the angle formed now? Initially, the minute hand is 90 degrees behind. So now, he travels 187 more. We can use the 87 degree minus the 90 degrees behind will be 97 degrees in front, right? So we get the angle is 97 degrees. So this is a question that we know the time and we calculate the angles. On the contrary, if we know the angles and we can calculate the time, it just works as the same. We know the angle, we know the difference on degrees. So use the difference on degrees divided by the difference on speed. We can calculate the time. And the question will be solved. Just remember that every angle on a clock has its direction. That is a plus angle and a minus angle. Do distinguish it, and that will help you. But here comes a more difficult questions come from the 2022 on a 3-point question. So it asks that from 5 a.m. to 12 in 7 hours, how many times will the minute and hour hand form an angle of 120 degrees? So it's not actually about the actual time, actual moment. It's about how many times that this case happened that they form the angle of 120 degrees. Now this is another type of clock problems which need us to calculate the time those two hands form a certain angle. Sometimes this angle is very typical, like 90 degrees or 180 degrees, which means that they form a line here. And then sometimes we ask how many times that they overlap. So all of this question comes from the origin of the overlap calculation. So let's see it. So for how long will the hour hand and the minute hand be overlap from the last time? It's about the tracing problem. So let's draw it. Maybe sometimes we see that the hour hand and minute hand are overlapped, they're together. Then minute hand will travel faster ahead, and the next time they get crossed, it means that the minute hand travels exactly one circle, which means 360 degrees ahead of the hour hand. So that's the moment they overlap again. So now we can know that the one overlap happens for every the distance difference divided by the speed difference, right? So this is 720 divided by 11, which can be written as 65,511. So this is a very important time as well. So we remember that for every maybe the 65 minutes, the hour hand and minute hand will get crossed and be overlap again. And in an hour, not in an hour, in 12 hours, that when the hour hand traveled for a total round, in 12 hours it happens 11 times. So this is an overlap. But when we are discussing these two hands forming a certain angles, we can treat all this problem easily as if we want to form an angle, there are two situations. For example, the 120 degree here. Now we can think about it from the overlap moment. Obviously, before the two can get overlap, there is a moment that the minute hand is behind the hour hand for a certain degree. And after the overlap, there will also be a moment that the minute hand is ahead of the hour hand for this certain degree. So for any degree except for 0 and 180, we know that each overlap before it and after it, there are 2 times when these two hands form a certain angle. For this case is 120 degrees. So in fact, for these questions, we just need to know what? We just need to know the time of overlap. Then we use the overlap to calculate the time when they form a certain angles. So let's see it out. The starting time is 5 o'clock and the ending time is 12 o'clock. So we notice that the overlap happens just in the 12 o'clock, right? So this will be the last time they overlap. Let's trace back. So as we can see that overlap happens every hour and 5 minutes. So the last time should be maybe like this. And the last. Now this is not very accurate, just 7 and 6. Maybe here. 7. Now 6 and 5. Maybe it's 5, 28 or 27 or whatever. Doesn't mind. So we can find there are 7 times of overlap. So we know that each overlap there, before and after it, there are always a situation that they form a 120 degrees, right? So let's start from here. So for the first one, the 529. Before it, will it form a 120 degrees? For this question, maybe we should calculate the angle formed at 5 o'clock. So in 5 o'clock here, right? So the angle will be 150 degrees. A minus 150 degrees. So as time passes, of course, it will be a time when we form a 120, right? So before the overlap, there will be a 180 degree. 20 degrees, sorry. So this is the first time. And after the overlap, the second. Then for this overlap, before, after, before, after, before, after, before, after, before, after, and before. So as we end the time at 12 o'clock, so there is no after. So now let's calculate the 1, 2, 3, 4, 5, 6, 7, 8, yes, it's to 30, right? So the time when it formed the 120 should just be 60 times. So this method can be used to solve any angles, any specific angle for maybe they get perpendicular. It's the same, right? But if they form a 180 degree, it's different. For 180 degree, it's just the same for plus and minus. So there is only one time. For each overlap, there is only one time they form a 180 degree. So the time of 180 when he formed the line is just the same as the overlap. It happens only 11 times in 12 hours. But each other circles, they happened 22 times in a 12-hour. So that is the question for today. So the angle calculation is very important, and we should master the method and get a point in NMOS round. Okay, that's all for today, and thank you, and see you later. See you in the seminar.